Hey, good morning. It's Tuesday, and I thought the first thing we would do is review or go over the Math 1 Unit 8 review. So I'm just going to go over all these questions. Hopefully you've completed it, and this should give you a good idea if you're understanding what we've tried to learn so far in Unit 8. Okay, number 1, what is rigid motion? Rigid motion is when a transformation retains size and shape. Okay, and the three transformations we're going to be studying: translation, which is a slide, rotation, and reflection, which is a flip. Those three transformations all retain size and shape. They are all rigid motion, retain size and shape. Okay, moving on to number 2. Name the transformation that is occurring between the two trapezoids. Is it rigid motion? Okay, this is a rotation. You can see kind of this point is rotating here. This point is rotating 90 degrees here, rotating 90 degrees here, and rotating 90 degrees here. It is a 90-degree rotation counterclockwise, and it does retain size and shape, so it is rigid motion. This would be a 90-degree counterclockwise rotation. Okay, moving on to number 3 through 8. I gave you this first one when x and y don't change, but the y becomes the opposite. That's a reflection over the x-axis. This guy, x stays the same, y minus 1, which means this would be a translation down 1. You don't necessarily have to say this, but you would be moving your image down 1. Okay, this is a translation as well, and you're moving 2 to the right. All right, number 6. Okay, we can see that our x and y switched places. Okay, and our new x became the opposite. So that is a 90-degree rotation counterclockwise. When you rotate counterclockwise, we go this way, so I think of that's pointing at my new x. So my new x becomes the opposite. In a 90-degree rotation, your x and y switch places, and since we're going counterclockwise, the new x becomes the opposite. Okay, here you can see that x and y stayed in their original places, but they both became the opposite. There's two possibilities here. This could be a 180-degree rotation, and that's more likely since there's only one thing going on here, but this also could be a reflection over the x and y axis. Okay? And number 8 here, what's it? This is a translation again. We went 2 to the left and up 3. It's a translation. Remember, a translation is a slide. Okay, name 3 transformations that will map the shape onto itself. What this means is, how can we move this, or how can we what transformation can we do, or how can we move or change this without it looking any different? And what we're saying is, 1, you could do a 90-degree counterclockwise rotation. That's 1. Because if we rotated 90 degrees, we could just turn the paper and you would see that it really didn't move. It's in the same position. So that's 1. The second one is we could do a reflection over the x-axis. And because if we reflected it over the x-axis, it would just flip, and this side would go here, and this side would come here. Be a reflection of the x-axis. And the third one, we're just going to have to repeat one of our rotations. We could rotate it 180 degrees. Or, you know what, we could reflect it over the y-axis as well. Okay, moving on, number 10. Triangle ABC has been rotated 90 degrees counterclockwise about the origin to produce this image. Name all congruent angles. Okay, so this is our pre-image. So this guy rotated here. So we have angle A is congruent to angle T. And angle B rotated all the way over there. So we could say angle B is congruent to angle R. And angle C rotated over there, so we can say angle C is congruent to angle O. All right. Now, since that's the case, you can hopefully see that AB, or line segment AB is congruent, so we have AB is congruent to TR, line segment TR. And then we can say BC, you can see that BC, line segment BC is congruent to, let's see, we went BC, so that must be RO. And finally we have CA is congruent to, you can see where we have CA is congruent to OT. And you can see CA is congruent to OT. All right. Let's see, number 11 through 17, use the following graph of quadrilateral PLAY. Play. If play is translated up 5 units and to the left 8, what are the coordinates of a P prime? Well, let's just start off. P is at -3, 0. So first let's write the rule. Let's do that. Let's write the rule. So that would be translate 5 up 5 units and 8 to the left. So it's going to be x minus 8 and y plus 5. Okay, so if P is at -3, 0, then P prime should be at -3 minus 8, or -11, and the y value for P is 0, so 0 plus 5 is 5, so P prime should be at -11, 5, up 5 and to the left 11, so it's off our chart there, or off, up 5 and to the left 6. No, 8, sorry. Okay, moving on. Number 12. If play is reflected across the y-axis, what are the coordinates of L prime and y prime? Okay, so remember, reflecting over the y-axis, the rule is x and y stay the same, but since we're going over the y-axis, your x becomes the opposite and your y stays the same. So let's see. L is at -1, -5. So L prime should be at the opposite of -1, so +1, -5. And you could see that would be, we're reflecting across the y-axis, so it would be right here. So your L prime would be right there. And let's see, y is at 5, 1. So y prime is going to be at -5, 1. Your y becomes, your x becomes the opposite, y stays the same. So -5, 1. And that would be y prime. See it reflected over the y-axis. Here, over the y-axis to here. Okay, number 13. If PLAY is rotated 90 degrees counterclockwise, about the origin, what are the coordinates of A prime and L prime? So let's write the rule. So when we rotate 90 degrees counterclockwise, we switch our X and our Y, and since we're going counterclockwise, our new X becomes the opposite. So A is currently at 4, -5. So that means A prime is going to be, we switch our X and our Y, and left, our new X becomes the opposite. So A went from 4, -5 to 5, 4, right here. There would be your A prime. Okay, now we need to do L. So L is currently at -1, -5. So L prime will be, we switch our X and our Y, and our new X becomes the opposite. So it should be at 5, 1. So 5, -1. So L prime would end up right here. Okay, and it rotates 90 degrees, and A would rotate 90 degrees. Okay, number 14. If PLAY is reflected across the x-axis, what will be the slope of line segment P prime Y prime? Okay, so let's go ahead and reflect PL. So remember, P is at -3, 0, and L is, no, PY, excuse me, Y is at 5, -1. So if we reflect them across the x-axis, remember, X stays the same, Y becomes the opposite, so it's -3, 0. It doesn't move because there's no opposite of 0. And we get 5, +1. So what we end up with is just this line segment right there. Okay, now we want the slope. So let's find the slope of P prime Y prime. So P prime Y prime, the slope would be, remember, rise 1 and run 1, 2, 3, 4, 5, 6, 7, 8. And what do you think the PY slope is? Well, hopefully you know it's -1/8, down 1/8. If play is rotated 290 degrees counterclockwise about the origin, what will the slope of A prime Y prime be? Well, remember, rotating 270 degrees counterclockwise is the same as rotating 90 degrees clockwise. So if we're going to rotate 90 degrees clockwise, remember that's this way, so what happens is X, Y switch places, and since we're going to the right, our new Y becomes the opposite. So let's see, A is at 4, -5. So A prime is going to be at -5, 4. And let's see, Y is currently at 5, -1. So our Y prime, excuse me, is going to be at, we switch them, and our new Y becomes the opposite. So A prime is going to be at -5, excuse me, -5, 4. Where's -5, 4? Let me see here, we switched them. -5, 4. And so, oh, here we are. Oh, I'm sorry, I knew something went wrong here. A is at